Next section, 4.3, is called the Pythagorean theorem. All right, Pythagorean theorem has to do with the side lengths of a right triangle. Before we do anything with Pythagorean theorem, let's review the special parts of a right triangle. Obviously, a right triangle has a right angle in it. The other two angles would be acute. The two sides that make the right angle are called the legs. So leg and leg. The side across from the right angle is called the hypotenuse. The two legs we are going to label as A and B. Doesn't really matter which one's A or which one's B. And the hypotenuse will be called C. The Pythagorean theorem is probably the most famous mathematical relationship. The theorem states that the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. So what does that mean? Using our variables up top, leg squared plus leg squared equals hypotenuse. In other words, a squared plus b squared equals c squared. It doesn't matter A or B, which comes first. It does matter that C is by itself, okay, where A and B are the legs and C is the hypotenuse. That's it. That's the lesson for today. Now we're just going to do lots of practice with that Pythagorean theorem. So your first step is figuring out which side's the hypotenuse. And problem number 1, x is the hypotenuse. So make sure that goes by itself. We're going to do 6 squared plus 8 squared equals x squared. If you switch 6 and 8, that's fine. 6 squared is 36, 8 squared is 64. Add those together. Take the square root. It's a whole number, so x equals 10, and we're done. Remember, the hypotenuse is always the biggest side, so if you get a number smaller than 6 or 8, you did something wrong. Number 2, once again, x is the hypotenuse, so x goes by itself. It doesn't matter 4 and 9 what order they go in. 4 squared is 16, 9 squared is 81, 16 plus 81 is 97. X equals root 97, which is not a whole number, so you can leave it as root 97. It's approximately 9 point something, but root 97 is fine unless you are asked to round. Number 3, in this case, 15 is the hypotenuse, so make sure 15 goes by itself. So x squared plus 12 squared equals 15 squared. X squared plus 144 equals 225. Subtracting, we should get 81. And taking the square root, we get, technically we get plus or minus 9, but this represents the length of a side. A side cannot be a negative length, so just 9 is our answer. And the last one, number 4, 8 is our hypotenuse, so make sure that 4 goes by itself. But 8 goes by itself. 2 squared is 4. 8 squared is 64. Subtracting 4 and taking the square root. Again, technically we get plus or minus, but it's got to be positive, so it's just root 60. You can leave it like that, or if you know how to simplify radical expressions, the actual answer here would be 2 root 15. But root 60 is fine for us. Next slide, these will get a little bit tougher, so let's take a look at number 5. X is the hypotenuse, so make sure x goes by itself. So 6 squared plus root 18 squared equals x squared. 6 squared is 36, root 18 squared is 18, because the root and the square cancel out. 36 plus 18 is 54. Take the square root of both sides, you should get root 54. So x equals the square root of 54. Again, if you are into simplifying rationals, that would be 3 root 6 would be our answer for that one. Number 6, once again, x is the hypotenuse, so make sure x goes by itself. So we have 5 squared plus x minus 1 squared equals x squared. 25 plus, now for x minus 1 squared, I'm just going to do this work off to the side over here. X minus 1 squared means x minus 1 times x minus 1. If you distribute, you get x squared minus 1x plus 1, which is x squared minus 2x plus 1. And that equals x squared. Okay? So combining like terms on the left side, we get x squared minus 2x plus 26 equals x squared. Now if I subtract x squared from both sides, guess what? They're going to cancel out. And that leaves me with negative 2x plus 26 equals 0. Add the 2x to both sides. I get 26 equals 2x. Divide by 2, x equals 13. So here's a problem I'd like you to try. Go ahead and pause the video and try this on your own. Come back when you are done. All right, you can see the work there. You should have got 16 is equal to x. X plus 4 is your hypotenuse there. And then when you finish, x equals 16. All right, the converse of Pythagorean theorem is basically the same thing. It's basically going to give us three numbers, and we're going to figure out are those three numbers the sides of a right triangle or not. To do that, you're simply going to check the Pythagorean theorem and see if it works or if it doesn't work. The big key here is you have to make sure you put the biggest number by itself, because remember, our hypotenuse is the biggest side. So in problem A, when you set up the Pythagorean theorem here, make sure that 8 goes by itself. It doesn't matter the order that 5 and 3 go in. So we have 25 plus 9 equals 64. 34 equals 64. Clearly that's not true. So this is not a right triangle. Letter B, 5 is the biggest number, so make sure that goes by itself. $25 does equal 25, so this is a right triangle. Go ahead and try C and D, and come back, pause the video, come back and check when you're done. All right, for C, you should have got no, that is not a right triangle, and D, that is a right triangle. That is it for section 4.3, the Pythagorean.